Hey guys, today's lesson is on section 4.7 and it's called the inverse of linear equations. An inverse relation or an inverse equation is made by exchanging the x and y values. So it's the opposite or the inverse of the function. Remember, we were talking about relations and functions in the beginning of the year, and a couple ways we could write relations or functions is as a table, as a or set of ordered pairs, and a graph. So what we're going to do is find the inverse of the following by exchanging x and y. We're literally just switching the x and y values. So for problem 1, the relation is shown to us as a set of ordered pairs. For each ordered pair, to find the inverse, we're just going to switch the x and y value. Remember, the x value or the x coordinate is first and the y coordinate is second. So the inverse of the first ordered pair is 1, -2. We're just swapping their positions. The second ordered pair, the inverse would be -4, 3, 7, -5, and -1, 0. Very simple to find the inverse when the function is written as a set of ordered pairs, a table, or a mapping, or a graph. Number 2 is shown as a table, and remember, a table is just organizing ordered pairs in a table form. The first ordered pair would be 1, 2, so the inverse would be 2, 1. We're just going to exchange or switch the x and y values. Our second ordered pair, 3, 0, is 0, 3. Our third is -3, 4, and our last would be -2, 6. Notice we're not changing the signs of any of the numbers or any of the values. We're just trading or switching the x and y values. For number 3, we're going to graph the inverse of the line. It sounds a little bit more complicated than it is. What you're going to do is just pick 2 ordered pairs anywhere on that line. There is a bunch that you could pick from, any ordered pair on the line, but all we need to do is pick 2 out of those. So I'm going to pick this ordered pair and this ordered pair. The first ordered pair I picked is 1, 2, and the second ordered pair I picked would be -2, -1. What we're going to do is find the inverse of those 2 ordered pairs, plot them on the new coordinate plane, and then graph our line showing the inverse graph of that first graph that you see in number 3. So the inverse of 1, 2 will be 2, 1. I'm going to plot it. And the inverse of -2, -1 would be -1, -2. So I will go ahead and plot that. The inverse graph and the regular graph, they do look very similar. However, as you could see, those ordered pairs are on different spots than the original equation. This line actually moved below the origin. It moved a little bit further down on the coordinate plane. Finding the inverse relation when the function is written as either an ordered pair, a table, or a graph is fairly simple. Our next page, we're going to see how to write the inverse equation of a given linear equation, and that will be our second page here. We're going to start off basically the same as the first page, where we're going to exchange the x and y value. We're literally just going to switch x and y. Where a y is written, I'm going to write x, and where x is written, I'm going to write y. The next step for finding the inverse of an equation, however, is now to solve for y again. So notice I first switched the x and y, and now I want y to be solved for or be alone in the equation. So in order to solve for y, you're either going to add or subtract first. In this case, there's subtraction. They're subtracting 8, so I'm going to do the opposite and add. X plus 8 is just x plus 8 equals 4y. And then now to solve for y, we're going to do the opposite operation. 4 is being multiplied to y, so we're going to end up dividing by 4. Remember, the whole point of this is now to solve for y again, in which this resulting equation is going to be called the inverse. So 4 divided by 4 is 1. We're going to get y equals, and on the left side, we're now going to write it on the right side, is just x plus 8 divided by 4. We can't go any further in simplifying this expression because of this variable here. X plus 8 is just x plus 8, and then that value divided by 4, we're just going to represent it as x plus 8 over 4. This is our inverse equation. Step 1 would be switching the x and y values, and then step 2 would be to solve for y again. Let's go ahead and head on to number 2. Again, first step, switch x and y. Second step is to solve for y again. So I want to isolate or make y be all alone on one side of the equation. So I somehow have to get rid of the 1/2 and the 11. Steps to solving, you always first look for something to add or subtract. Since 11 is being added to the 1/2 y, we're going to do the opposite and subtract to get x minus 11 equals 1/2 y. And now let's think about how we should get rid of the 1/2. 1/2 is being multiplied to y. So we're going to do the opposite and divide 1/2 on both sides. How do you divide a fraction? We're going to multiply by the reciprocal. The reciprocal of 1/2 is 2, so we're actually going to multiply 2 on both sides of the equation. 1/2 times 2 is 1, so we'll just be left with y equals. And 2 times the entire left side of the equation, we're going to distribute to get 2x minus 22. Now that the y is all alone, we solve for y again. This equation here is the inverse of our original equation. Let's go ahead and look at our 2 below. In order to find the inverse, the first thing you'll do is to switch or exchange the x and y values. So x equals 2 times 2y minus 6. And we now want to solve for y again. Every time we see parentheses with a value outside or being multiplied, we're going to first distribute. 2 times 2y is 4y. 2 times negative 6 is negative 12. And now let's continue to solve for y. In this case, we're going to add first because it's the opposite operation. We'll add 12 on both sides to move it over to the left. X plus 12 is just x plus 12. And similar to the first problem, the last step would be dividing by 4, in which there's nothing that we could simplify on the left side. So we'll just have our equation y equals x plus 12 divided by 4. This equation is the inverse for our original equation. We switched or exchanged the x and y values, and then we solved for y again. Here comes our last equation. First thing we want to do is exchange or switch the x and y values and solve for y again. So here's the y value. If you remember a couple chapters ago, when an entire side is being divided by one value, the first step we're actually going to do is multiply both sides by that denominator or that number at the bottom. The 2's will cross simplify, and on the left we'll get 2x equals 2y plus 3. To continue to solve for our y, we'll first now subtract 3 on both sides to get 2x minus 3 equals 2y. And lastly, we'll divide 2 on both sides to finally solve for our y, getting the inverse, y equals 2x minus 3 divided by 2. There's nothing further that we could simplify here, so we'll just leave it as it is, and this equation will be the inverse of our original. Please let me know if you guys have any questions on the lesson, and I'll talk to you soon.